Welcome back to a new video in my C++ tutorial series. Now, in today's video, we want to continue on managing our pre-make builds. So previously, we have configured premake just a very vanilla default way. We have written our premake.lua file, have done some workspace configuration and some project configurations, and we were even able to specify the project name using a variable to kind of like automatically set the right location, set the right name, and have everything been automated correctly. However, this is not what we want to do in the future. This is not how we want to roll, because, well, we do not want to copy paste this for each project that we have. And also, if we copy paste them in this file here, you can see that we are already taking like, what is this, a bit like 12 lines per project. And if you do this for like our, like, what are we having like with this exercises, like 10 projects, you can like see you're gonna get like a file that is like 300 lines long, and it's gonna be not very manageable. So what I want to do today is I want to actually factor this out into multiple files and make these single files even smaller than they are currently. Now, the first step that I want to do is I want to put all of that into one file, right? I want to put this into one file that is related with the project. For that, we're actually going to go back to 09 ini-pp. Alright, so how do I put this into a new file? Well, what you're going to do is you're going to create a Lua file, and it makes sense to create this Lua file inside the project because it's related to the project. And what I like to call it, I like to call this build.lua because this is the file that is kind of like specifying how to build this with Lua. So the general idea is that you are taking all of your project configurations, you're moving it out of that normal premake5.lua, and you're just going to blindly paste this into the build.lua file, and yeah, now it's in a different file. If I would rerun my, where is it? Output? No, this is what? Where is my console? Close this terminal, new terminal. Yeah, there it is already. Here it is. If I run my DevTool again, you can see that it's no longer working because, well, Visual Studio, there are no solutions with our projects. And if we are doing this like that, we're going to have a solution with our projects, and that's not how it works. So obviously, it doesn't work because we removed it. Now, how do we get this back in here? Well, it's actually quite similar to C++. We're going to include it. And from where we're going to include this? From ./09 ini-pp build.lua. And if I do it like that, we include this other file, and Lua does not have a complicated include system like C++. If we just plainly include this, run it again, it is gonna work. Right? Now the solution has been regenerated. If I do this, we're gonna have our ini-pp correctly configured. Well, and until now, we have the exact same behavior that we also had last time. However, now we have it nice separated into two files. Now, if you want to go on with cats and dogs, what you could do is you could copy your build.lua, paste it into cats and dogs, take the name of cats and dogs, and yeah, paste it in here. And since this is all handled with variables, if I now run this, it doesn't change because we need to include this. Forgot that here actually. So let's also include this one. That's also something that we could automate in the future, but yeah, I have done a bit of research on how to automatically include these Lua files. It actually works on Lua quite simply, but it is kind of like a bit hard to understand. However, if we include this now as well, you can see that it also now generated a cats and dogs solution and or project, and it refreshed the solution. And if we now go in here and reload, you're going to see that we now have two projects, cats and dogs and ini.cpp. So we already improved our workflow. I mean, yeah, still, if we're creating a new project, we need to copy that build.lua file. Now, this would be fine if there wouldn't be one big drawback. If we do change anything in here, like for example, we want to have a different target directory, output directory, we need to change all of these build.lua files. And that's not how we want to do this. That's definitely not how we do this. We want to do this simple. We want to do it as simple as possible, and in general, just specify the project name. And yeah, how are we going to do this? Well, we are going to do this with functions. We're going to write a function that is going to set up our project based on the project name. Now, how are we going to do this? Well, we could write that function into the premake5.lua before the workspace or somewhere where it makes sense. However, what I like to do, put this function in its own source file. So what I do is I create a new source file in here called the cpp tutorial.lua. I always tend to call this like the project or put this into a subdirectory scripts and then like stuff, but for the most simple ones we're just going to call this one cpp tutorial.lua, which is then going to be included in our premake5.lua as the first thing that we do. So the first thing that I do is I include cpp tutorial.lua to basically add all the functions that are in here. Now, Lua also has like a global state that is modified. So in Lua, if you include something and it defines a function, it is available after the first include. So we do not need to include this into the actual Lua files. This is different on C++. Because on C++ we need to have it included in every source file if we need this, because the preprocessor is set and it's all compiled separately. All C++ source files are compiled separately and then linked together. However, in Lua it's a global state. You start at one file, the global state is modified, and if you're calling include, really what just happens is that a different file is loaded, compiled to the VM code, and then executed. So Lua is more like, I know, Python maybe, I'm not quite sure. No, Python I think works a bit different, but yeah. In general, Lua has a global state, and if you include, it's basically just a copy and paste the code in here, if you want to speak in this and make this a bit more easy. Now, what we want to do is we want to actually put all the code that is currently in our build.lua into our cpp tutorial.lua, and now we want to decorate this with a function. So how do you do functions in Lua? Well, you just call the function keyword, then you're going to give the function a name. For example, we could call this new project or something like that. And then we can actually give it parameters. You could give it default parameters, but that doesn't make sense. So function new project is how we're going to start a function in Lua. And functions are going to be stopped in Lua by calling the end keyword. Now, of course, we don't want to have the end keyword in here. We actually want to define everything there. And then somewhere down here, we want to provide the end keyword. Why is it intended? No, there we want to have it. Okay. So now we have basically the whole project set up in a function. The function is called your project with a project name and somewhere end. And what I tend to do, I tend to give it a prefix. This is just how I like to do this. You can like differentiate this from the premake functions and stuff. So I always tend to give it some prefix. I'm just going to call it CPT for CPP tutorial. CPPT new project basically means a new project in CPP tutorial. I tend to do this like that. It has some advantages and disadvantages. A disadvantage is that if you're copy and pasting your Lua build files into a different project, you need to rename the functions. It's a disadvantage if you have a prefix. If you have a prefix, the big advantage is that you are not going to assume something, because this is going to change, right? For every project, your new project function is going to be different. For every project you write, a tutorial is going to have a different setup than your application. At some point, you're going to add some defines or some custom configuration that is just valid throughout the scope of your project. And by explicitly prefixing this, we are kind of like aware that this is not a normal, just a new normal project. It is a normal project on your scope. You could also do this like that, something like new CPPT project, CPP tutorial project. However, I always tend to prefix them because later on we're also gonna have more functions that operate on that, and by having more functions, always good to see they all start with the same prefix. And now what we really want to do inside of our build files, we actually now want to remove all of that code that is actually creating the project. We want to remove them all. And instead of having them in here, we basically call it function. So really what we do is we call the function new CPP project. We could also do it like that, would also work. New CPPT new project, then the project name would also work. Could do this like that. However, since we're going to have arguments in the future for that project, I do want to make them as a function call, right? Something like that. And if we do it like that, actually, it should work very simple and it should still work through. What I'm going to do is I'm going to copy paste this to the simple CPP app as well, so that you see that it's really working by providing some new stuff. Because normally on Premake, if you don't change anything, even through the Lua source code change, but the solutions don't change, you really don't see a difference. This is why I'm just adding the simple CPP app so that you see that it works. Now, if we're adding the simple CPP app, we of course also need to include this one. And again, this could be automized, but not in our case, actually. In our case, automation would be hard to do, really hard to do, because we do not have all of our projects in a subdirectory. In a subdirectory, you can just simply iterate over all directories that you have and then include the build.lua file inside this subdirectory. All right, so that's how I do it. And now I've run the DevTool again. You can see we have a few changes. And if we are going back into Visual Studio, you can see that we have a reload and everything still looks good. We have a new project in here. We have the existing projects in here. And now you can also see that the build.lua file, it's also there. It's actually even in the project browser because we added the Lua files and we can actually open them up. And we also get syntax highlighting from Visual Studio, which is good. So now you have like your config.ini, you can actually see your build.ini, and you could even edit your build.ini from Visual Studio. There is like no way to actually live hot refresh this in Visual Studio. There might be a way that you could do, but this would revolve that you still need to do a manual step to basically say, all right, now make a pre-make build and then reload the solution. But as you can see, still, it's looking quite good and it's looking quite easy, right? Because it's really, really versatile. It's versatile because what you do is you just write your build files, and if you add a new project, the only thing you need to do is you need to copy the include directive and you need to write the CPP new project, and everything is automatically following after that. All right, so now let's actually talk about libraries, right? We have used libraries in C. The ini-parser. This was a static or dynamically linked library, depending on how you like it. And this library was basically not producing an exe file, so not a console application. It was producing I'm just going to say, a static lib. However, since we have now changed our build system, this is no longer a static lib. And what happens if we copy and paste our build.lua? Well, we could try this out. Build.lua, take the 04, ini-parser, put it in here, run premake. Premake should run fine if we include this, what I always tend to forget because I am lazy, and that's why I have spent quite some time into actually making some research on how to automatically include premake files, but that's a different topic. We might do this in the future on a different project here. So ini-parser, let's add this one in here, and let's call the DevTool, run it, and let's also let's also do the ini Explorer, because we can actually now see two different issues that we're gonna have if we add both of them that we need to solve, right? And also include that one. 1 second, go in here, ini-parser, ini Explorer. Let's copy and paste this in here, and let's rerun. Okay, seems good. Go back to Visual Studio, reload. Now we have two more projects in here. We have the ini-parser and the ini Explorer. Now let's try and build these two projects. Let's start with the ini-parser. Let's right-click the ini-parser and say build. And, well, you're going to see a few warnings. It's actually okay. Oh, it says inconsistent DLL linkage. Did I specify this as DLL import and DLL export? Okay, so we have done a few things where we need to check into account what this is, but this is actually just a warning. We don't care about warnings. Okay, we care about warnings, but yeah. But what you can see is that we have an unreserved external symbol main in function invoke main, whatever. So actually what happened here is it tried to find a main function, but it couldn't find one. Well, obviously, because this is a static library, or it actually, from what I've used here with Deckelspec import and output, it's actually a dynamic linked library, but that's okay. We can do this as well. And what you can see is that we have an unresolved symbol, and having the unresolved symbol, it is bad. And you can see it's not working. It's trying to build an application out of a static library. And we also have an issue with the ini Explorer. If I build the ini Explorer, we cannot open the include file, ini-x.h. We don't have that include directory because, well, it's not specified. And if we even would specify this, we would still have problems because we can't link to the ini-parser. So let's start and actually fix these issues. Now, first of all, the ini-parser itself. The ini-parser uses the function that we have predefined. So the ini-parser build.lua file creates a new project, and the new project in general, it is setting the kind to a console app. Now this is a problem because now all of our projects that we're going to create with create new project are going to be console apps. Now what we can do is we can actually mutate these kinds. At least I think it should be possible, but we're going to see. Now in general, this is fine. We can collapse this function that is doing what it should do. However, what I want to do is I want to have a function where I can later on say that this project is not a application, but a static or dynamic link library. So what I want to do is cppt, I write into a function, set static lib, or since we're going to use dynamic libs, use dynamic or set dynamic lib. Just a little void function here on Lua, and what that's gonna do, it's gonna set the type to, I think it's called shared lib actually, but so set shared lib. That's what we want to do. Now, if we set this to a shared lib, we need to also take into account that we might do more things. So in general, what I tend to do, I tend to most of the time call the raw Lua functions in my build files at least as possible. So if I do something like creating a project, setting is a shared lib, I always write these as functions because later on you're going to see that this set shared lib is going to do more things than just setting the kind to shared lib. So that's what we want to do here at the first thing. So let's actually copy this now and go to the ini-parser build.lua, and what we want to do is we want to call this function additionally to the new project function. If I run this, it should have changed, and it should now be a dynamic link lib. If I would go to the ini-parser, go to properties, we should see that it is a dynamic library, DLL. So this has actually changed. Let's now try to build it again. And you can see that it has actually built it, but it still gives you a few errors. The problem is that we are using this ini API, and you can see that this ini API is currently evaluating to DLL import. Remember, if I go to my ini-parser, we had the ini API.h in here, and what this basically has done, it has, depending on what preprocessor macros were set, it has defined ini API to DLL import or DLL export. However, what we have as a problem in here currently is that we have not defined this preprocessor macro. So ini build DLL is not set. Now, what I want to do is I want to automate this. Now, how can I automate that? Well, I can automate this by basically providing a macro that is automatically set and called build DLL. And now we actually need to alter the code that we have done previously, but you're going to see in a second why. Because what I want to do is I want to have this in a uniform way, right? As soon as you are kind of like defining this as a shared library, I want to automatically define that. So what I want to do is I want to add defines. Now, normally in premake, I already told you the last thing is going to override something. However, on things like files or defines, if you are supplying the command again, so if you're calling defines with that one and then you're calling defines again, it's not going to overwrite the old defines. It's actually concatenating the defines together. And this is a very useful feature because what you want to in generally do is have multiple parts of your application that of your Lua application here that are going to provide different defines, for example, like set shared library. So it's useful and good to know that this is not going to replace it. This is actually going to concatenate them together. So what I want to do is I want to provide this build DLL macro. However, I'm not going to call this one ini build DLL because this is now not universal usable. What I want to have is I want to actually use a token. I want to use a token in here in this define and call this like project.name. So project.name build.dll. This is the token that I want to do. So we have the project name and then the underscore build.dll. That's always going to be set if we are on a dynamic linked library. Let's rerun this and see what it does. Let's go into Visual Studio. Let's reload this one. This should still not change. However, if I go into my ini-parsers properties, I should see that some macro has been set in the preprocessor. A define has been set, and the define that has been set is 04 underscore ini-parser build DLL. So that's the macro that has been set. And I can copy that one down in here. And this is actually not going to work because it starts with the 04. And this is now going to bring us to a different error, but we could solve this. For example, if you have an underscore, it works. And just for the sake of making this just simply work, I'm just going to add the underscore in here as well, so that it's directly defined with the underscore, which is going to remove problems that help. And actually, I'm a bit of an idiot because underscores can break, I think, on GCC sometimes, or some compilers or versions have problems with leading underscores. So let's do a double leading underscore and reload this and provide the double leading underscore here as well. And now you can see we have the define ini-parsing build DLL. And this is now gonna provide us a quick and easy way to check if one project is built as a DLL or not. Now, in general, if you have some weird project names, this can also fall apart, but for now, this is actually fine for our purpose. It's automatically set if it's a DLL, it's dynamic, we do not need to hardcode anything, we just need to be aware that this macro is set by default. You could also now provide a similar macro if it is not a shared library, however, this would now mean that we would either need a different function or in general have something defined. But what we could do is we could have a normal macro that's always going to be set. We could write this somewhere here and just call this one underscore build without DLL, so that we have also a way to detect which project is currently built. And this is also a useful way, right? You could also kind of like do this with an if-def. If this project is built, it's gonna DLL export that, and otherwise it's gonna DLL import this. And you could write some advanced logic around it so that you can actually decide if it's a static library or dynamic linked library. But in our case, we just want to stay simple here. So let's run premake again. This is going to change a few things so that we can reload all. Now, it always depends on what changed, how Visual Studio is going to provide you that prompt on if you want to reload. But in general, you just want to say always reload, no matter on what it tried to tell you to reload or not to reload. All right, so now this provides the correct macro for the spec export. And if we now go to our ini-parser and we're going to build this, we should no longer get warnings. Yeah, we have no warnings in here. It has generated all the code. And as an output, we also have the DLL in here, 04 ini-parser.dll. Alright, so this fixed our ini-parsers build. Now let's see if the ini Explorer actually works. Now let's build that one, and well, you can see the first issue that we have is that we can't open ini-x.h. How did I try to open this? Okay, I defined this like that. I directly use it as a path. Now, what you in general want to have is you would want to have an additional include directory. So what I in general do is I provide include directories. You can do this in premake as well. I think we have talked about them. Include dears are the include directories, and you can provide several paths on where you want to include. What I in generally tend to do is I tend to always provide the project's location as an include directory and the workspace's location. So project.location and workspace as location as an include directory. Now, if we do this, we need to actually alter our code to go into the subdirectory of the ini-parser. For now, this is okay. What you could also do, but this is something that I then wouldn't do inside of this tutorial lua.file, but directly in here, is provide the include directory in here and do something like include dears and provide an additional include directory here to go to something like workspace location 04 ini-parser and manually provide this in here. There it is fine to actually call it in here because this is not just on a per project scope. But in general, what you would do if you do this in a good practice way is that you don't need that one in here. You don't need it. You can remove it. And inside of here, you want to, instead of directly including it like that, you want to include the ini parser, and then you want to like include ini-x.h. This is how you want to do it the proper way. Now you can see that we still have an error here if I build that. Let's build that one quickly. No, that was a wrong project. That here, ini explorer, come on. No, ini cvpp is built here. Let's wait a few seconds until that build is done. ini explorer, build that one quickly. You can see that we get an error. Please define exactly one default format. So actually this error is the error that we have manually defined. So we want to define one of these formats. We want to use the default format 1 here in this case, just for simplicity. And now this is something that definitely goes inside of here. So definitely this goes into the defines there. Defines always need to be an array, even if you only provide 1. Now this is directly in here because this is something that's definitely just on a per project scope, right? Same on here, the ini parser, it used shared libs, only used here, it's also used there. So what you really want to do, you want to have a minimal configuration overhead in your actual build files. In this case, it's setting the macro. And if I build that one and reload that, the macro should be set, and ini data ready 1 should be there. Now we could try and build this again, which is going to also give us some more problems. It's going to give us some problems that we have unresolved externals. We have unresolved externals because the functions that we were trying to load were coming from the DLL, and since we are building a DLL, we need to manually give Visual Studio a hint that it also should use that DLL to use that static link library. Now, what you can provide is you can provide links. So links are linking projects or actual libraries. So what you can do is, if you're providing this links macro, you could directly define a project name. This is the most simplest way to do it. And if you are providing a project name, it's automatically going to do everything for you. What you can also do is you can directly provide the .lib file in here where you want to link against. But if you are doing this with a .lib file directly, I think, do they have some examples? So like my library, it's automatically including the library, but you could also provide... they do not provide an example on directly including a .lib file. For example, Windows does come with a few .lib files, the 3d12.lib, for example. You could also supply them in here, but then you need to require to set up all the directories and paths by yourself. So what we in general just want to do is we just want to call the links, and I want to link with my project 04 ini-parser. And if I do that and run that tool again, and reload in Visual Studio, you're going to see if I right-click the Explorer and build it, it built it fine without any issues. It produced the ini-parser.dll, so you can actually see that it manually compiled the ini-parser, and then it also compiled the ini-explorer, so it was kind of like aware that that exe is using the ini-parser, and therefore it built the parser first and then the explorer. And if I would go to the explorer and go to like build dependencies, project build order, you can actually see, or if I go to dependencies, it's a bit easier to see that it depends on 04 ini-parser. This is all set it up correctly, and you can also see that ini-parser is built before the ini-explorer. This is like the build order. The only thing that really matters for us is that ini-parser is before the explorer. This is the only thing that's important here for us. Now you could also see, if I would open this up here, that we have this reference tab, and in this reference tab you can see the 04 ini-parser because we are referencing the ini-parser that is in our solution. So premake does all the setup correctly that you would expect. Now what I could do is I can run this, I can click the ini-explorer, right click, set a startup project and start the debugger, and everything should still work. Okay, now you have a usage, ini-parser pass to ini-file, optional format. Okay, so at the ini-parser use some command line arguments, so you can see command line arguments. It's called like config.ini or the default.ini. I think we use config.ini. So let's provide the config.ini here in there so that we can properly debug that. How can we provide that? Well, we need to provide debugging arguments, debug args, very simple. You provide the macro here, debug args, and then you can define the arguments as an array. Very, very easy. That's what we want to do here as well. So inside of here, or we wouldn't even need to go inside here, but later we do need, because we need to run the build tool. So what we want to define debug args in here, and the debugging arg that I want to use is config.ini. Very simple configuration here. Run premake again. It now generated this file here that includes the debugging arguments. Visual Studio is not detecting that I should start it, and you're going to see that it does not work. Well, why does it not work? Well, the problem with Visual Studio is that it does not auto-reload the .user files. The .user files are user configurations, and debugging arguments inside of Visual Studio are per user configurations. And it's not inside that solution file. The debugging arguments are not in here. They are inside the user file. Okay, they are inside that user file. So if you would show in here, you can see that local debugger comment arguments is config.ini inside that user file. However, that user file is not automatically hot reloaded by Visual Studio because Visual Studio does not expect that file to change externally. Bit of a pity. You can solve this by restarting Visual Studio. Let's reopen that up. And if I restart Visual Studio, then you're gonna see if I start it, then it should work. Let's run it. And it's going to now output the correct output because now it has applied the debugging arguments. You could also later on, if you are not want to restart Visual Studio, you can also copy paste them in here, but that's not really the point of having a build system. All right, so this was quite some undertaking to get all of that working, but what we got out of that is really good, right? We have some really verbose and simple things that we do. Creating your project, give it a name, give it a define for that format, linking against the parser, giving it the argument config.ini, right? Same here with the parser. Creating your project with the parser, set it as a shared library. It's a DLL now. Everything is going to work. Everything is going to be set it up automatically. Now let me quickly also make all the other projects built. Advanced C structs. We also want to have that in here. I'm just going to copy the simple one, memory utils, pointer, simple C app. Let me quickly copy all of them in here before I'm going to start changing them. All right, simple C app, pointers, memory utils. No, wrong. There we go. Memory utils, advanced C-Songs, I think I already customized. Okay, like that. Now we have a build file everywhere. We can rerun this and it will not change because I, again, am the idiot who forgets to include everything. So we need some 06 in here. 3, 2, 1. 01, simple C app. 02, pointers. 03 memory utils, 4, 5, 6, 06 advanced C structs. All right, now we have all the includes in here. Let's rerun them. 1, 2. Where's my 03 not generated? That's interesting. Why did you not generate that one? Interesting. Has it already been generated? No, can't be. Okay. Interesting. Why is it not generating that? Interesting stuff. CO3 memory utils build? Huh. Now it has built that. Okay, so I had a typo in there. But if I go in here, reload the whole solution, we should get a few more projects in here. And what I can do to quickly verify that everything works, I can right-click the solution and build solution. We're just going to build the whole solution, and we should get like that 6 succeeded and 3 are up to date, which means that 9 projects have been built. 9 projects are in here. So that's actually good and as expected. So everything good here. That's nice. Now, the only thing left to do is to add the last project in here, and that last project is going to give us some problems because that last project is in a subdirectory, and because it is in a subdirectory, it is going to screw our whole setup of builds, right? Because subdirectories are bad. Subdirectories are a a bit of a problem, because it is in the exercise subdirectory. And if it is in the exercise subdirectory, it means that we cannot set our location as simple as we have done it here. Previously, we have set our location of the project to the workspace location and to the project name, which worked fine. However, now we are in a subdirectory. So actually what we can do is we can no longer use the project name as a subdirectory. So what I can do is I can provide another argument and call this one let's call this one source to see where it is. And what I want to have is I want to have a source directory. By default, the source directory is gonna be the project name, and only if source is available, we're gonna do this. And I'm not that big of a Lua expert, so I'm gonna give this a quick Google search. Lua, check if argument or if variable exists. I know empty variable check is the thing that I want to do. If not empty var, then yeah, let's maybe do something like that. If not source, or if if source not equal nil, I think nil, is it in there? We could try and do this. Let's say then and say something like source dir equals source. This should hopefully work, and now we can use that source dir in here and provide this as a separate argument, and this should okay. Then expected, so we have a problem. Why do we have a problem? If empty var, if not empty var, then I think not equal was different in Lua. Was not equal in Lua, I think was that. No, it was not that. This is the only thing that I find a bit odd on Lua, how not equal. Lua not equal sign. It's that one. Okay, so this was already the right thing that I tried to. Okay, so now if we can see, if we add this argument, it didn't change anything. No project files have been changed. However, we should now also have the option to provide a different location by adding a new parameter in here. Let's see if we can use that. Let's copy that build.lua. Let's go into the E0 functions, and let's try to also provide a path for that. Now, this is now called something like E2 E01 functions, and it is in a subdirectory called exercises, and I'm always lazy and copy paste stuff. So this should now hopefully work correctly. Let's see. We also need to include that one in here. And how can I include that one? Well, I need a full path. Exercises E01 functions build.lua. So if I do this like that, it hopefully works. Let's run this, and yeah, it generated exercises in that subdirectory. It generated a solution file, and if I reload that, it is in here. It looks good. Taking a look at this, let's try to build that. And yeah, it succeeded. One succeeded. Okay, so we actually managed to get it in. However, you're going to notice that we have one thing that's not as expected. Previously, I had my exercises into a folder in Visual Studio, right? We could add a folder here. No, this is a filter because I'm on a different view here. But what I could do is I could add like a solution folder, and inside of the solution folder, I would then queue the E01 functions project in here. And there's actually also a way to do this on premake. There is a command called group. We might want to take a look at the documentation because I tended to always do this. So there's something called a group, and a group is a workspace group, a virtual folder to contain one or more project. And it should be appeared in ID, and a set group may be created by separating the names with forward slashes, something like test util, to group them together, right? This is what we can do. And we should also be able to end a group by providing some empty arguments to close the group. Now, I want to provide this here, and I also use the indent style that I like to use. And what I want to do is call that one exercises. to group them nicely together. Then I can run the command again. It regenerated the solution. That was already looking good. If you're gonna get that one, conflict file modification deleted, always detect that, always say discard. It's important that you say discard, because discard means discard the working state of Visual Studio and take the one from premake. If you are saving that or overwriting or ignoring it, it's bad. You always want to click discard to discard your modifications from within Visual Studio. And now, boom, you can see it's under that exercise folder, E01 functions. And now what we have is the exact same setup that we had previously. Now that we just have invested like 2 times 40 or 50 minutes to set this up correctly. And yeah, that's the way you want to do it, because that's easy. Because if you now want to add a project, easy. Create a new folder, create a file that might be as simple as that. And if it gets complicated, it might be like that. But yeah, like in 4 lines, having a whole new project that is customized and runs exactly how you like it. And just with these few changes, we are there at some very, very dynamic and nice build systems. Next video, we're going to talk about external dependencies, because external dependencies, using libraries is important, and using libraries correctly with package management is a thing that you want to consider. And that's why we're here. Learn it the proper way. Thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.